Hello everyone. We are going to pick up where we left off in our notes packets today. I couldn't be here with you today, so I am going to make you a little video to finish out this section. Now, before we left each other on Tuesday, we talked about the measures of arcs, and these were the last examples that we talked about. So remember, if you only have two letters, it's a minor arc, and a minor means acute, so it's got to be less than 180. If we have three letters, it's a major arc, which is greater than 180, kind of like an obtuse angle. So a couple properties that I want you to be aware of. I kind of have these pre-written down. If two minor arcs are congruent, then their corresponding chords are congruent. Now remember, a chord intersects the circle in two places, however, it is only a segment. So if the minor arcs are congruent, notice my tick marks, then the chords themselves are also going to be congruent as well. So I've got my information that matches over here. All right, feel free to hit pause at any time if you need to kind of slow down so that you can draw some of this. That's kind of the beauty of having the video, is you can hit pause at any time, so keep that in mind. If one chord is perpendicular to perpendicular bisector of another chord, then the first one's a diameter. So this one is a 2-for-1 special. It's perpendicular, which means forms a right angle. Bisector means we are chopping it in half, so we have two congruent pieces here. All right, so if this is occurring, since AB bisects and is perpendicular to CD, therefore AB is a diameter of the circle. All right, but you have to have both properties in order for AB to be a true diameter. Okay, and the reverse is true. If a diameter is perpendicular to the chord, then the diameter bisects the chord and its arc, which is important to note. So if this is truly, if a diameter is perpendicular to, then the diameter bisects that chord. Okay, so this chord is getting bisected as well as the arcs. All right, so those arcs would be equal. Those arcs are going to be congruent. AB is the diameter, therefore they bisect. All right, so I know there's a lot of information there for you. Feel free to hit pause at any time. All right, so let's look at this first diagram here. If AB is 110, then we can find BC, because look, their chords are the same. So if their chords are congruent, then their corresponding arc measures are congruent as well. So they both measure 110. All right, so the opposite is true. This time they're giving us AC is 150, which is going to be this arc right here. And I know that in the whole circle is 360, right? So if I take 360 minus the 150, I should have 210 left over. Well, since these are congruent, I've got to divide by 2 so that they are equal measures. So when I divide that by 2, I should get the 105. All right, so there's the first one. And then notice here a couple things. We've got arc CD and we've got DE over here. Now, since this is a diameter, I know that if this is a right angle and this is a diameter, then therefore these two are congruent. And if those are congruent, then their arcs must be congruent as well, which is why I have this equation up here. I know that 9x has to be equal to that arc, and then I can solve for x that way. Now, make sure you're answering the question though. It really wants to know, what's the measure of CD? Well, I'd have to plug in the 8, and then I'd have to plug in the 8 down here as well. So I know 8 times 9 is 72, and then 80 minus 8 is also 72, so it all works out. And then those arc, that arc plus that arc would give you the 144. All right, so we got one page left, and I'll walk through these with you. I just kind of had those written down ahead of time. Okay, let's look and see what we got here. We are looking for X. All right, well, if I know the entire circle has to add up to 360, I can take 360 minus the 220 minus the 70, and the only thing that should be left is 70. So if these arcs are the same, then my chords must be the same, which means this has to be 12 centimeters. Okay, let's look at the next one. IJ is 10, so this segment is 10. So I'm going to try and draw that in here. HA, the whole segment is 11. And we want to find this segment over here, AK. Okay, let's see what we got. All right, so this whole arc is going to be this arc right here. If I add these two together, should be 80 degrees. And then this arc is going to be an 85 degree, A to H. Do you see that? So the measure of AH, I should write it this way, equals 85. And the measure of IJ, if I go from I to J, is 80 degrees. Because they have that 25 overlapping. So I really need to figure out, okay, what piece is remaining here? If I know that the whole circle is 360, then I need to figure out, well, what's that remaining degree measure going to be? So I can subtract all of that from 360. 360 minus the 140, minus 55, minus 25, minus 60. And I have an 80 left over. So if that arc is 80, then it matches my IJ, which is 10 centimeters. Okay, next one. All right, look, we've got perpendicular. I know that this is a diameter because it passes through the circle by definition, or passes through the center by definition. So therefore, these two are congruent. It is bisecting. So therefore, x equals 7. Okay, this one looks interesting. Now, if all of these arcs are, or excuse me, these are chords. If all of these chords are congruent, then all of their arcs must be congruent as well. So if that's x, then I should have an x over here, and I should have an x over here. So how many are there? 1, 2, 3. Plus the 27 should be the whole circle, 360. Minus the 27. So therefore, x has to equal 11. All right, hopefully you're doing all right so far. Feel free to hit pause or rewind if you need to hear it one more time. That's always helpful. Okay, paying really close attention to my tick marks here. Chord, chord, which means these arc measures are congruent as well. Here's an x, so this guy over here must also be an x. And then these are gonna be the same measures as well. Okay, so let's think about what we know. We know that this is a diameter, and diameters equal 180, correct? So if I take 180 and I subtract the 88, I'll write that down, subtract the 88, then I have 92 left over. Well, I know that I have to divide that into 2 equal parts. So if I hit divide by 2, each of these is 46. So then that means that has to be 46 as well. So then by the same logic, if I want to solve for x, this side has to be 180 as well because it's the other semicircle. Okay? So I'm going to take 180 minus the 46, and that gets me 134. So that's that semicircle right there, 134. And then I divide by 2 to find 2 equal parts, and I should come up with 67 degrees. All right, doing all right. Okay, so now we've got several things going on here. I know every piece of this circle except this piece right here. So the way that I'm going to tackle this is I'm going to take 360 minus 91 minus the 78 minus 113. Minus 113, and that leaves me with 78. So therefore 78 corresponds with 78, so my chords must be congruent right here. So X has to be 9 centimeters as well. Okay, next up, 74, my chords are congruent. So if my chords are congruent, then by definition, their arcs have to be congruent. That was a gimme question, that was an easy one. All right, so what can you conclude about each diagram below? Okay, I might give you a minute. Think about the special properties, look at what you're given, and then think about, okay, what kind of statements could I write out? What kind of conclusions could I make about this diagram? Go ahead and hit pause and see if you can answer that question. Okay, so let's look at some of the properties that we have here. I see a perpendicular bisector. So therefore, by definition, AB has to be a diameter. All right, in addition to that, if these sections are being bisected, then their arcs are going to be equal as well. So therefore, arc AC is congruent to arc AD because it's bisecting the chord and the arc as well. All right, so this one, I know that this is a diameter, so therefore, I have two congruent sections here. I wish I would have put a center here. If we put a center here, let's just call it, we'll just call it A. All right, so then I know these are being bisected. So I know FA is going to be congruent to GA. All right, and that's because we knew number one, it's a diameter, number two, it's perpendicular, so therefore those two are being bisected, which means then arc FH is congruent to arc GH. All right, so that wraps it up with arcs and chords. And I have a worksheet available for you today, as well as a little review activity. So thanks guys, and I'll see you when I come back on Friday.